then I'll accept so that you can record. After that, you can share with your colleagues. If not, we will share. Normally, the size of the Zoom, because it will take hours to record, is huge. Sharing it on WhatsApp does not favor it. So unless you create Telegram, yes, that one is easier to upload the file there. That is easier to upload it. Okay. One of the first things we look at is introduction to advanced biostatistics, an introduction to it. And if I should take you back from where we believe you have started from, like you have done biostatistics, and then this one is about an application of the statistics in biological sciences, in particular in the field of medicine, in the field of health science, in the field of public health, in nursing, in midwifery, in any field which is related to biological sciences. So the people who learn the statistics, they are there. However, we have people who use the statistics in their work, and that becomes an application of it. So even if you can quote the formula for a mean, the formula for a t-test, however, you cannot use it. The results it will give you cannot interpret it. You are not applying it very well. So it's more about the application of the concepts in it. Number 2 on this same score is that the biostatistics is, I'm doing a research and I need 1, 2, 3, 4 statistical tools. Which of them is the most appropriate? Meaning that in your field, when you're doing research, you cannot do it without knowing how to apply some statistical tools. And that is why the name is a biostatistics. So it's not just you're learning statistics, but it is an application of the statistics you are learning. Okay. So biostatistics is the method used in dealing with statistics in the field of medicine, biology, public health for planning, conducting, analyzing data, which arises in investigation of these branches. So except when you're doing qualitative research, where statistical tools are not important. If you're doing quantitative or the mixed methods, you need those statistical tools to work with. Advanced biostatistics is not just about statistical tests that researchers suddenly need. However, it is the need to know a few important things about statistics. So that is the idea there. Like I want you to have that picture. So we look at this thing in so many contexts. But before we proceed further, Now we are 6. Together with the 2 of us, we are making 8. I want you to go and look for some statistical tools. And then when you come, you tell me what you will use it for. At least each group will give me 2, a statistical tool, and what you will use it for, so that I know that you remember some of the things you have learned. So don't worry, you'll be fine. So that's what I create a group for you, say 2. And then you go, you look at it. 15 minutes will be okay. Then you look for any statistics you have learned and what it is used for. Why do I need it? When you are able, we will come back and enjoy ourselves. Okay. If you fall, we'll add you to it. If you do not fall, that's better. Let me see. I want to be sure today how it will go. Sorry. Unfortunately, that makes one group only 2 members. You leave where?
It says you can send one.
I will. All right, welcome back. I think I've seen that except to one person, the networks seem to be good, and that is important. Okay. My group 1, some members fell off, but Halidu is there, and then Janet. Tell me anything that you discuss. So you pick a presenter, you put up your hand, then we'll call you. So Halidu and Janet, who is presenting? Okay, Janet. The 2 of you, your hands are up, so you didn't decide who will present. All right, but Janet first.
Okay, good morning, Doc.
Good morning, all.
And good morning, everyone. So
Okay.
we were able to find out 2 statistical tools.
Okay.
And the number 1 tool is the hypothesis testing.
Okay.
Okay, so we were able to find out that it is used to find out the relationship between 2 or more variables.
Okay.
Yes, and then we also got to know that we have 2 types. That's the alternative hypothesis and then the null hypothesis.
Okay.
Yes. So our
All right.
second tool is inferential statistics.
Okay.
Yes, and that one too, we found out that it is used for sampled data to draw conclusions or to make predictions about the larger data or the population.
Okay.
Yes.
That's great.
So,
Okay, so I want to add small to what you just.
All right, Halidu.
So the hypothesis that we discussed, we also realized that maybe you predict about something, then you now subject it to a research.
Okay.
So either you now reject it or you accept it.
Okay.
That is why you now get the null or the alternate hypothesis. So for example, if you say maybe the cause of a death of a person is maybe diabetes or hypertension, then you now put it into the research to find out whether there's a relation between the diabetes, hypertension to the cause of the death of the person. Then you can now either accept it or you reject that
Okay.
notion. Then the influential, if I come to a population of a larger population where we want to conduct a research, let's assume that we want to find out the HB level of pregnant women, but we realize that the population is very large. We can just a sample of them so that when we are able to find it, we use that result to give a generalized view of the entire community.
Okay, that's better. I'll comment on it when I finish with the next group. Yeah, group 2 now also have 2 left there. Unfortunately, I added Joyce to it, so I'll remove her. Yeah, Aram and then Samuel. So you put up the hand, we'll call you. So Aram and then Samuel, who is presenting. Okay, Samuel.
Hello, Doc.
Yes.
Doc, please, we also look at mean.
Okay.
Okay, so Doc, please, we said that the mean is the average set of numbers or any data you want to deal with.
Okay.
And then it provides a measure of central tendency, giving you an idea of the typical value of the data set.
Okay.
Then, please, we spoke about median.
Okay.
And then we said that it's the middle value of a data set.
Okay.
That is a range from the smallest to the largest. And it is used for understanding the central tendency of the data set.
Okay. That's also good. I don't know if Aaron also want to contribute there. If not, I'm okay. All right. So some of them you have done well. Some of them too. Some are out of also coverage area. But that is the beauty of it. Okay. I take you to that group 1 had the word inferential statistics, right? But I was looking for example. So example was not given, but that statement, inferential statistics, is there. But there are variety of them. So it means that you mention a name of a group. And then group 2, you went for central tendency. The mean and the media, they serve almost the same purpose. The differences are based on some other technicalities which we will learn. If not, they serve the same purpose. Okay. Hypothesis testing. Good. It is where the statistics come in a lot. When we say we are testing hypothesis, but the hypothesis testing is not a statistics. But that is where the researcher comes in a lot with variety of statistical tools to use. And then we say the person has applied them. So in your field, the person has become a biostatistician. It's normally when you state hypothesis, it's where the beauty is. And that is what we'll be doing. So the biostatistician should have a hypothesis. Read through in it. There are certain things in it that should inform the biostatistician which statistical to pick. So the example you gave about the cause of death. Okay. So if it is a hypothesis that the person is testing, there are things there that he has to base his argument on, or her argument on, to select them. So you have done well. But from the 2 presentations, 2 things came up, and they are the statistics. A descriptive statistics and inferential statistics. The group 2 mentioned mean and median. That is a descriptive. The group 1 went straight with inferential. Example that will be meeting in this course include t-test, ANOVA. These are the inferential. The one who wanted to check the relationship, yes, Helity. It means that we look for an inferential statistics which can be used to ascertain a relationship. Okay, like Pearson or Spearman, they are there. There are so many of them. Some also like chi-square. There are so many of them. So these tools are there. But what you are doing will inform which one to select and apply. So this is where our learning is taking us to. This is where our learning is taking us to that. If I have these two, which one of them should I select is dependent on the research question I've written, the data I've collected. Please hold on small for me. So sorry for that. So that is what you have done. You have done well. You have done well. At least you have mentioned that, but that tells you that there's also a job ahead that we are going to do. There is a job ahead that we need every one of you on board to make it interesting. If you have questions, ask. If there are none, I move on. Okay, so I was on this slide that I asked you to do that for me to see. So when you're applying the statistical tool to become a biostatistician, we say there's the need to know some important things about the tool you are going to use. So for instance, in building a model, so let me take you to one of the models I have on the slide. You look at it, maybe you observe it carefully for say a minute, and then I will ask you a question about it, what you have seen. All right. Any contribution? You put up a hand, I'll call. It's just an image which is there. What meaning have you read into it? Yes, Janet.
So, Doc,
I can see that there are two poles at the top, which is the
Yeah.
real life.
Okay.
And then the good fits look exactly like the real life or the real
Okay.
world.
Okay.
And then the moderate fit has only just one pole.
Mhm.
And then the poor fit has no pole. And I don't know if it's stones or
Like
yeah.
any way you see it, what meaning will you make of it?
I'll say there is a depreciation.
Okay. And then the politicians, they will need you. You understand their terms. All right. Okay. Another person. There is a depreciation. Okay. Yes. Another person. The others. The iPhone, I've seen that you come and then you fall off. But please do change the name for us. Say, click on the three dots. The option of renaming will come, then you rename. Or if I should rename it here for you, you tell me your name. I will. Okay. Any other contribution? Oh, there's more you need to say about this. So it's an image, a beautiful image. It's an image. Wow. Yes, I've seen another hand. Yes, Sammy.
Doc, please, I can see that we have the real world at the top,
Mm-hmm.
and the real world has been dispersed, and then we have three category of people
Mm-hmm.
based on their health have been categorized under the real health.
Okay.
So we have those who are healthy, they
Mm-hmm.
are skewed to the left,
Okay.
and then we have those who are moderately healthy, they are in
Okay.
the middle, and
Okay.
then those who have poor health, they have been skewed to the right.
Okay.
So please, that is what
That's
I see.
also
And then,
better.
all right.
That's also better. At least
Yeah.
you have related it to your field. Janet related it to depreciation, which affects almost everyone. And then you have also related it to health condition. Joanna,
Okay, so Doc,
yes.
I see it in a way that in comparing, if you want to compare something,
Yes.
anything that it looks exactly to what you are being compared, what is being compared to is a good fit.
Okay.
So if in another way, if you are comparing and that particular thing you are comparing with
Mhm.
is somehow not the same as the original thing you are comparing, it is a moderate fit. Then
Okay.
when a wide difference between the original one and what you are comparing with becomes a poor fit.
Okay.
That's how I would.
Okay. That's better. I think we are doing well. Yes, Halidu.
Okay, Doc, what I
Yes.
can see is assuming if you are at the field and you approach programs,
Okay.
maybe with this notion, it means you cannot approach every program with the same how do you call it? The same approach. You
Okay.
can't tackle every program with the same approach. They all come with
Mhm.
variety. So you will need, so it
All
means
right.
if poor fit is a problem, how you approach it will be different from that of the moderate fit and that of the good fit too. But
Oh,
in
Okay.
all,
nice.
you are aiming at bringing all of them to one, let's say one skill.
Okay. That's also better. Okay. From where I also sit, okay, I also imagine it that I have two things Then I want to create something to fit them. And then as a biostatistician, I am thinking of what to do to fit them. So if I pick the one who spoke about the inflation, you could see the profit means that if this is how we assume that pricing of commodities should be, we will not go for the profit. It will not serve our purpose. And the citizens will be agitated. Somehow, the moderate fit may do something for us, but it will not serve the purpose entirely. So I will not go for it. I want to get the one that fits the ideal or the real world. That's what I want to go for, the one that fits it. Because the real world is what, let's say, I am imagining. If this were to be how it is better. Okay. So the one who used the health is the same. And then the others, your argument are the same. But I use this as a model to justify a point. So I say that statisticians, they build a model. And I'm using that I have two towns which I want to construct a bridge. But before I do that, I say in social sciences, what you are doing, you are a nurse, you are a midwife, a laboratory technologist, wherever you are. Okay. And that's where you work. But the aspect of your research that you are doing can be considered to be as if it's a social science. You're not doing the laboratory and picking a sample to examine to see what is in it. So in social sciences, we are usually interested in discovering something about a phenomenon. The cause of death, that's a phenomenon. It exists. The cause of death. I was happy with that example. The phenomenon can be anything from the behavior of a child in early childhood to the behavior of undergraduates at the end of semester examination party. Good. I like the inflation. It's a phenomenon. It is. And we experience it better. We can talk about it better in Ghana. Because everybody talks about it. Whatever the phenomenon we seek to explain, we collect data. Anything. So I go back for cause of death. We collect data. Malnutrition, we collect data. Those who give birth to normal unit and then the abnormal ones, we will collect data. How these things happen. How diabetic patients go for physio, the exercise, check their sugar level, we will collect data. OPD attendance by Ghanaians, possibly emergency ward, we collect data to analyze and to make inferences. So the biostatistician's job is to take available data and use them in making meaningful things. So the diagram we'll see, it's like it's a model. This is the thing in my mind. This is what is happening. So how best do I solve it? The biostatistics, the reason for building statistical models of real data is best explained by this analogy I have given. Everybody does that. So if you don't select it very well, you get it wrong. You have done it. You have had your findings. You have drawn conclusions. But the way you thought of it is making it wrong. So the diagram I have there, the image, I say, imagine an engineer wishes to build a bridge across a river. That engineer will be pretty that if she just built any old bridge. We have seen gone are the days, those who stay in Accra, circle was popular. All right, how do you want to record? That's better. Circle was popular, and Chroma circle, Tetekwashi, this. Now, I don't think those words are popular anymore. They call them interchange. In every regional capital, wish that there are interchanges there. Okay, they built one for us, those in Kumasi, at somehow be in Asaf Market, and then Sufulai. Now they say they are doing one at, I think, Swami. So you see, it was Swami roundabout. Now they are changing it. Those who know that. Now they are doing some in Secondary Takrady. They have a flyover which they call interchange at Tamale. Good. So you could see that they have gone there to put a pillar here, a pillar there, and place something, and they say, was this what they wanted to do? The people will be disappointed. And that's how picking statistical tools and using them is. You may have done it right, it can be used, but it will not attract people. Okay. So the engineer will be pretty that if she just built an old bridge, because the chances are that it would fall down. Instead, the engineer collects data from real world, and that was the picture I gave. She looks at the bridges in the real world and sees what materials they are made from, what structures can be used, and so on. That's how the work would do as the statistician. She then uses this information to construct a model. So a lot of the research, people construct model from the statistical tools they apply. They conduct it. The model may differ from reality in several ways. It will be smaller for a start, but the engineer will try to build a model that best fit. And that's why we come here. I have two terms. This is an old way of conducting bridges. It's an old way of conducting bridges. They seem to be modern, but unattractive in bringing the two towns together. Okay. They seem to be the most appropriate. Yes, serve the two very well. You look as if it's a flyover, it's an interchange, it's this, it's that. So my point is that you know a lot of things, but as you applying a biostatistician, you need to think through of the data you have collected and see how best you can analyze them. And there's always something in the things we collect that tells us that this is how you should approach it. And that's why these three things are there. They have all approached it. I'll say, no, this one there, it's not good. Oh, no, somehow. Yeah, that's better, you have done well. And where we are only looking for the statement, that's better. And that's how it is. Every day, we are thinking of building it. So as I mentioned earlier, in building this, there are two things we use. Either we describe it or we do inferentials. And earlier on your contributions, you did well. That you have a large group, a population which is very large. And you cannot handle everyone. So you sample some. Normally, most of the statistical tool can allow you to use a sample size of 30 as your minimum. Wait small for me, I'm coming. So there are two types. There are two types that will deal with in biostatistics. We have the descriptives. We have the inferential. Let me use my further illustrations to show them. Okay, my further illustrations to show them as this. So some people, they use graphs. Some people, they use, we call it basically charts. Some people, they use some percentages. They use means and their standard deviation. They use mode. Okay. So if we finish with the December election, they will say somebody had 50 plus 1% and has won the election. That is, we are describing it. Okay. But if you want to see details of certain things, we say no. Let's do the inferential statistics. Okay. So the difference between the two is that descriptive statistics are used to summarize a sample's characteristics using statistical measures. So it's all about the sample. You don't make it to other group. Now the inferentials are used to draw conclusions about the population from the sample at hand. So if you want to see people that are benefiting from a postnatal services, those who go for weighing, that's what we have been told. You need to be at the place, the sub-unit where they are doing it. Ask them their number of mothers they expect. If they expect thousands, you cannot say you want to work with all of them. You may sample some, work with them, and then use what you have to say this is what is happening at this point. Descriptives can describe the actual sample you study, but to extend the conclusion to a broader population, we use the inferentials. To use inferentials, you have to be sure the sample you study is representative of what you want to generalize. Yes, this statement is there, but the biostatistician has options. There are all the inferentials come with some basic assumptions. When you violate them, there's another door that you can pass through it. So before you select a particular inferential, you need to tell your readers, the one you are submitting the report to, the thesis maybe in future you will come and write when you do the topper. You will need to tell whoever is reading that I was supposed to use this. I couldn't use it because of the violation of this. Now I'm doing this. You are permitted to do that. So every inferential statistics, which we call parametric, has a friend, which we also call a non-parametric. So whenever you violate the parametric, you go and look for the friend. and then you work with. I am just trying to clarify point 4. To use inferentials, you will need to be sure the sample you study is representative of the group you want to generalize over. And I'm saying that this is an assumption. Even if it is violated, there's a way out. Any question? Any question? Okay. And then on, we march on. So I also use this diagram. Yes, Halidun.
Please, Doc.
Yeah.
The influencer statistics where you want to pick a sample.
Yeah.
And work with the sample, is it determined on the population of the area, or it's an assumption of you, the researcher? So let's assume if there are two communities, one is having a population of 5,000, one is having a population of 30,000. Can you use the same sample size for the two communities?
Okay. So we have various methods of sampling. The one studying research methods with you will talk about them.
Oh, okay.
So if I have 30,000, let's say 15,000, I forgot the examples you use. And I can put them all together to have 45,000 and use simple random to select them. That is a probability sampling. You are right. It depends on what the researcher is looking for. Number 2, if the communities come with different characteristics, and I am interested in the characteristics they bring on board, I can say I want to use stratified random sampling because they have different characteristics I want to study. So you select from different groups. The two you select here, you select there. Number 3, if the sample size has got something to do, and then we say you're using proportionate stratified random sampling. So you go and refer to the one of the cheapest table we make reference to is called Creasy and Morgan. If I have 15,000, how many? If I have 30,000, how many? If not, there's a formula we use to calculate for how many should take from each group to achieve proportionate random sampling. So there are other things there, but the inferential work with when you have done the right random sampling is when the biostatistician can apply an inferential statistics. But if a probability sampling was not done, then you cannot use it. You only go for the non-parametric of the right statistical tool you should have used because you have violated the assumption. Alido, I don't know if I have answered your question very well for you.
Doc, I'm okay with it. Thank you.
Good. Even if not, as I move on, it's still early days yet. I'll be answering some of these questions as I move on.
Okay.
Any other question? Okay. Now I have given you these two images to also depict the same argument. The bar graph in the figure 1, and then a distribution, a normal distribution in figure 2. Okay. So if you check this, if you have heard teachers like using the word a normal curve, there are people who are here. There are people who are also here. There are people who are there. Okay. So here, everybody is brought on board. So whenever you make any comment based on this, it can be said to be affecting the whole population. So the numbers that are used to summarize and describe data will come as a descriptive. But if the sample is a set of data taken from a population to represent the population, the probability distributions are the best. Hypothesis testing is the best. Correlational testing is the best. Regression analysis is the best. In that case, the value that will come out can help us to make such generalization. If not, we can only talk about a few instances. So let me give you an example. Once again, that when we finish elections, some people say they are posters. They predict what will happen. You can see at times it doesn't work. It is not that they didn't do research, they did. But their prediction is based on descriptives. It's based on descriptive. Their prediction is most undermined by how sampling was done. Currently, we have 16 regions. You know, when you step in some of the regions, it sways. When you step in Ashanti region, it's likely MPP will have the highest vote there. So you go there and then you come and see that, oh, per survey done in Ashanti region, MPP will win the election by 80%. They are daydreaming. They are daydreaming. Okay. Because that's a stronghold of a political party, and definitely either the government is performing, current and MPP or not, they will still have a high vote there. Okay. So as if you step maybe in a voter region, and even the MPP has done massively well there, it still remains a stronghold of NDC. They say per the work they have done there, they will get 70%. That one, I think when it's left, you have no wake up. You are still sleeping deep. Okay. Because the percentages you are talking about and the sampling done may not be a representative of the group. And hence, you can only describe what is the 50% will do this. And that is why the changes occur. And so his prediction wasn't good. No. But if the person has to use inferential, the error margin would have been minimal. The error margin would have been minimal. So those who are able to give us something about the health status, this condition, that condition, with the inferential status, they are able to make a good generalization, which represent even those you have never seen or met, and yet they will put up that behavior. I go. If you have questions, ask me, because gradually I am warming up into it. Descriptives, being deductive statistics, merely describe, organize, and summarize. So you note the word, it's merely describing it. The mean is this. Hence, they did well. Descriptives, okay, make reference to the actual data available, but not about the others. So I gave you an example here. Blood pressure patterns of a class of students, disease prevalence in the community, a case report. So I use the descriptive to say that, oh, in them, the blood pressure is this. They have high blood pressure, low blood pressure. A day is coming, you check the rest, and it's not like that. The inferential involves driving delivering the inferences beyond the actual data, the people you work with them. There are others you have not seen. Yet, you are making a conclusion for them. So, you did correlation, a relationship between somebody's BP and his weight. Like this year sandwich, all the students doing sandwich, and then you randomize, you select some. You check their BP and then you correlate it with their weight. And say this year students that came, their weight has a strong positive relationship with their BP. Any one of them you will pick should answer this right. That means that the sample selected truly represented, and that is where the inferential comes in. It involves inductive reasoning. Inductive reasoning. Picking 1, 1, 1, 1, 1, 1, 1, and going up. It involves inductive reasoning. Any question? Once again, these are just my intro to them to tell you that what we want to study under biostatistics, this is the purpose, why we need them. Everyone who wants to do research will need them. I study basic vocabularies for today and end, because I still suspect that we'll have other students joining. Basic vocabulary. Yes, it is. I'm saying that we'll use some terms. Now that you are here, you'll be using the terms. So we should know what they are. We'll be using them. One of them is a variable. It's a variable. A variable is a characteristic of an item or individual. A variable. So you'll be hearing them biostatisticians mention what variables were measured. What are they? Okay. The information we collect from people, the sample, the population, we refer to it as data. Data are different values, like the numbers you have assigned to a variable. So if you know your variable, yes, sir. All right, sorry for that. Okay. So you should know your variable. You should know the measurement you give to it, and then you take becomes your data. Why was your microphone on? Okay. Okay. So the variable values are meaningless unless their variables have been operationally defined. So there are days, the way you see it may be different from the way somebody sees them. So we always define them. Please, I am not referring to definition of terms, no. You define them. So I want us to go once again. You have been quiet for a while, to look for variables in your field, the area where you want to specialize. Look for variables, at least give me about three variables. I hope you get it. So I want you to go discuss among yourself the groups once again, and then you come back. Variables. I've recreated the groups because I want to have 3 members each in them. So look for a variable with an example in your field. This is a variable. An example is this. 3 of them. A variable with an example. After 15 minutes, you come back. Enjoy yourself. Yeah.
Yeah, I'll leave you.
Okay.
Pirates can I mean, assign. Oh,
Okay, welcome back. Yeah, all right. My group 1. What do you have for me? Who is presenting? It's Halidu, Sami, and Theodora. Theo. Who is presenting? Yes. Or you did not select anyone to present for you? Okay, then let me go to group 2. Aram, Janet, and then Joanna.
Hello, Doc.
Yes.
Please, we discussed about the qualitative and the quantitative variable,
Yes.
where we say the qualitative variable is a variable which individuals differ because of their characteristics. So we can
Yes.
talk about sex. It can be either male or female. Then we talk about the ethnicity, example of the qualitative.
Okay.
Then
Okay.
we spoke about the type of personality of the individual,
Okay.
also being an example of the qualitative variable.
Okay. You did well.
Okay. And we talk about the quantitative variable too.
Mhm.
We say it's a variable whose measurement results in numbers, numerical values.
Okay.
So we can talk about
the height or weight
Okay.
of an individual.
Okay.
Please,
That's
that is
better.
all. Okay. Thank you,
That's
Doc.
better. You have done well. And
Thank you, Doc.
a comment from group one, Halidu, Samuel, and then Theodora. You're all here, so or I should move on. Okay. Then I say
Hello,
you, yes.
Doc, please. So, this is group one.
Yeah. But why did it take you that long to even put up your hand?
Oh, Doc, please. Sorry, oh, we couldn't finish early, and then you came in, so
Hey, 15 minutes
we
here,
were not
there.
too sure. So please, that's why. So we were even talking. No, like we were still discussing when you came in. I was actually
15
outside.
minutes.
Like I'm not in the house. So like, hello, Doc.
Yeah, I can hear you.
Doc, please. Sorry.
That's all right. Let's move on.
Yeah. Doc, please. We look at ratio variables,
Okay.
and then we look at examples and narrators, height and weight.
Okay. Okay.
Then please, we also look at continuous variables,
Okay.
and then we look at blood glucose levels,
Mhm.
cholesterol levels, and then body temperature.
That's better. Okay. I think the two group you all did well. At least you have mentioned ratio, qualitative variable, quantitative variables. You have given an
Then we have
example. So I feel you have done well. And your examples were spot on. Meaning that you know that as a biostatistician, you will deal with variables. Please wait till I'm coming. Hello, Prof. Good. Okay, the points are good. You have done well. At least you have, I'm sorry for that. I think I have had an emergency, but I want to conclude the lecture before I leave. The points are good. It means that you have seen what we refer to as a variable, but we'll discuss them. They are good. Indeed, there are other terms also, which in reading a biostatistic material or research material, you have to meet. For the population, you have mentioned it severally. The sample, we have mentioned it severally. But what is a parameter? What is a statistics? Whenever you deal with a population, the measurement you have taken, the numerical measurement, is a parameter. When we deal with a sample, we say we are doing statistics. Let me show you one or two observations about what we keep on referring to as a population and a sample. So the bigger set here remains my population, but I cannot work with them all. I randomly select some. It doesn't matter where they are picked from. They still represent the population. So either the person took set 1 or set 2, they represent it, but as to whether that should be the minimum number to pick from this set is where we have sampling determination table or formula for calculating them. And anyone who wants to apply a statistical tool should be sure of whatever he has done. I show you another image. 2 examples to indicate what we mean by a population and a sample. Okay, so if you check the yellow color here from the birthday cake there, it looks nice. So when you're celebrating your birthday, go for one. All right. It may be that when you see the yellow color only, you may say that it is not well thought of. No. You check the individuals on it and see the colors they are wearing and come back to the figure. You will see they represent them. So as if you go for this crowded, if you see the sample taking, yes, you may say they are all here, but sample, you cannot study them all, so you always need a certain reasonable number to study, which we call a sample. This, your person teaching the research methods will dealt with them extensively. But I am interested in them because of the inferential statistical tools we use. You can only use it when you want to make a generalization to cover your population. So I have these as further examples. It's crucial, and that's why I have more than one example. So this can be a sample of this. This can be a sample of this. This can be a sample of that. This can be a sample of that. This is the population. That is the sample. If it is carefully done and you use any biostatistical tool on it, you will get the right results. Any question? If there's none, I end you here. God willing, Monday morning at 6:30, we'll meet. Janet, you send me the WhatsApp, send me your email. Then I'll forward the slide and the course outline to you.
Okay, no.
All right. If there are no questions, permit me to end here. Then I see you on Monday, 6:30 a.m. Okay, then bye. Enjoy your day.
Bye.
Bye.